All right, guys, so today we're going to continue talking about congruency, and this time we're going to get specific with triangles. So let's go ahead, and what are you going to learn today? We're going to learn about shortcuts that you can use to prove a triangle congruent, and then we're going to talk about coordinate proofs. You guys are going to love those, I know it. All right, so if I want to prove that triangle ABC is congruent to triangle FED up until this point, because I just taught this yesterday, you would have to show me that all of its corresponding parts were congruent. So that A would be congruent to angle F, okay? Angle B would be congruent to angle E, and angle C would be congruent to three of those, angle D. So that's what we would have to prove. We'd have to prove that those angles are congruent, and we would also have to show that all of the sides are congruent. So that AB would be congruent to FE, BC would be congruent to ED, and AC would be congruent to FD. Okay, so up until here, we would have to prove all of this. That can be really tedious and a lot of steps, right? But there are certain conditions that if they're true, it's sufficient to prove that a triangle is congruent to another triangle. So yes, there are shortcuts, and you're going to love these because it makes life a lot easier. All right, so what is my first shortcut? The first thing I have is a postulate that says it's called side, side, side. And we abbreviate it as side, side, side. You can use SSS. And so basically it says that if all three sides of one triangle are congruent to their corresponding sides of another triangle, then the triangles are congruent. So if you look at the two triangles we have, we see that UT is congruent to XY. We see that UV is congruent to XW, and YW, or WY, is congruent to VT. Okay, since all three of those sides are congruent, I can say that triangle TUV is congruent to triangle YXW. Okay, and order matters because we want to be able to look at this congruent statement and tell which angles are congruent to which and which sides are congruent to which. So that order does matter when we're stating them. So we can use this to prove that triangle CRB is congruent to triangle ABR. Now, I haven't stated any givens, but we have the diagram, and the diagram gives us the givens. So the first thing I want to do is I want to state those. So I've got CB, according to this diagram, congruent to CB congruent to AR, and I have CR congruent to AB, according to this diagram. Okay, so that's my given. Well, I have two sides that are congruent, so all I need now is the third side. Well, here is my third side, and that is BR. And we have a property that says that BR is congruent to BR. And that is the reflexive property of congruence. Okay, so we can just say reflexive. Now, if you look at the order here in these, it's kind of turned around. So it might even be better for us to say that it's congruent to RB. Okay. Now that we've got that congruent to itself, I have all three sides congruent, corresponding sides. So I can say triangle CRB is congruent to triangle ABR. And that is by side, side, side. And that's all we have to do is we can abbreviate side, side, side. So I know that you guys like that a lot better. That's probably the easiest proof we've done all year. 3 nice little steps. We can stretch it to 4 if we split the givens. But easiest proof we've done all year. All right. So a coordinate proof. A coordinate proof, we use the coordinates that we have and things that we know, like the distance formula, slope, midpoint, all of those kind of formulas that we can use to prove that things are true. So in this case, it might just help, just so you can draw a quick little picture, ABC congruent to DEF. Okay, and since all we have is side, 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 that means we've got to prove that the sides are congruent. So we're going to use your all-time favorite distance formula. Remember, that is the square root x2 minus x1 squared plus y2 minus y1 squared, and the square root of all of that. So looking at my diagram, I want AB congruent to DF. So if I'm going to find the length of AB, and I'm going to plug it in, I've got positive 3, because I'm going for the A's. I'm doing a lot of slope and stuff with algebra. So 3 minus a negative 2 squared plus the y's. We're going to put them in the same order. Negative 3 minus 1 squared. So that's going to give me the square root minus a negative is a positive. So 5 squared plus negative 4 squared, which will be 25 plus 16, which is going to be, and you guys know me, 41, the square root of 41. And you don't need to simplify it any further because we're going to match up the sides, right? So AB, according to our statement, should be congruent to DE. So if we take DE and we plug everything in, if I take 8 minus 3 squared plus 2 minus 6 squared, I know that that's going to give me 5 squared plus negative 4 squared, and that's exactly what we had up here. So I'll even let you skip that step, and we'll say that these are congruent. So far, we're checking out. We got AB and DE. So let's look at a different side. Okay. Let's go ahead and go with the BC and the EF. So BC is going to be the square root of 7 minus 3 squared plus 5 minus a negative 3 squared. So that's going to be 4 squared plus 8 squared, or 16 plus 64, the square root of that, which is the square root of 80. I'm just going to leave it that way because if I get the square root of 80, there's no point in simplifying. We could do it to practice, but if we want to get this proof done, we can just do it this way. So now we've got BC, and that's congruent to EF. So we're going to use this or not. Right? So EF is equal to 10 minus 8 squared plus 11 minus 2 squared which is going to give me the square root of 2 squared plus 9 squared, which is going to be 4 plus 81. So those aren't congruent. So we can say that this is not congruent. All right, so these are not congruent. So we were not able to prove that those are congruent. All right, so let's go ahead and move on. So that's nice. We didn't have to go through the whole thing because all three sides would be congruent. All right, the other postulate I have is side angle side, and we abbreviate that as side angle side. These abbreviations are important because if we look at the definition of two sides and their included angle on a triangle are congruent to two sides and their included angle on another triangle, then the triangles are congruent. So we kind of have to know what included angles are. This is an included angle because its sides make up the angle. This is my included angle. Its side makes up the angle. Okay. If I were to look at, say, E is not included, okay, because while FE makes up its one side, DE does not. So E is not an included angle. So when we do this, it's important that we have the included angles. So I've got a side, an angle, a side, an angle, and a side. So what we have is we have side AB is congruent to side no, we don't have side AB. We have, I was looking at that A there, we have side CB congruent to side FD, and we have side CA congruent to side FE, and then we have our included angles, angle C congruent to angle F. Okay, so we have a side angle side so that we can say then that triangle CBA is congruent to triangle FDE. Again, keeping our congruent angles and all of that lined up. All right, so here I've got a couple examples. I'm going to decide whether there is enough information to prove the triangles are congruent. If there is, we're going to state the postulate or the theorem that I can use to state those are congruent. All right, so look what I have. And I always like to draw a Z on here because that helps me to see, because we're going to do some tricky stuff. So I've got, let's actually use the highlighter here. This is parallel. So I've got this. All right. So that's good. That tells me that this is congruent to this. I have that side congruent to that. And then that leaves me with this angle side right here. Okay, that side is congruent to itself. So we say that yes, oops, I don't want yellow, that's hard to see. Okay, I have triangle. I'm going to start with NMO congruent to L, and with my congruent angle being the O here, triangle LO, whoa, don't know what happened, LOM, and that is congruent by side angle side. All right, now right now I've just got one side on the second example, but I have that these lines are parallel. So if these lines are parallel, Okay, I'm going to do this. So what that means, if those lines are parallel, is that my alternate interior angles are congruent. So alternate interior angles would be this angle right here, this angle right here. Okay. And then I've got this side congruent to itself. Is that enough to prove that these are congruent? And the answer is no. Because while I have two sides at an angle, if I look at this, I have an angle, or a side, and a side, and an angle. So I have SSA, or ASS. Well, guess what, kids? That's a bad word. So that's a bad postulate. It does not work. Okay, so these are not congruent. Okay, so today we have looked at, are there shortcuts to proving triangles are congruent? Yep, there sure are. And in this case, we have the side angle side and side angle side. And a coordinate proof is using points and things like the distance formula to prove two triangles are congruent. I hope you got a great evening, and I will see you in class mañana.